All right, folks, let's go ahead and finish up yesterday's notes. The only thing we didn't learn how to do yesterday was work our calculator with our trigonometry. And we got to learn how to do that today. So make sure you got your calculator ready to rock and roll. Now, look. This first one says to get an exact answer. And it's got quotation marks around it because, well, the exact answer for cosine of 30 we actually found yesterday. There's the exact answer for cosine of 30. It's root 3 over 2. All right, so let's go ahead and let's see what root 3 over 2 equals. So cosine of 30 degrees will be 0.866. So our calculator had better tell us that the cosine of 30 degrees is 0.866 because that is what root 3 divided by 2 equals. Correct? We see it? Awesome. So if you're using this awesome calculator, you just type cosine and then 30 and then close your parentheses and hit enter. If you're using the battery operated calculator, you have to type the argument first. So you have to do the 30 first, not like 31, but 30. And then you would hit cosine and it'll give you the 0.866, right? So we've got cosine, we put our 30 degrees in there, hit enter, and our calculator should say 0.866 and that doesn't say 0.866. Why does mine not say 0.866? Oh, it's in radian mode. How about that? You see, it says it right there. It's in radian mode. You can't do trig in degrees unless you're in degree mode. Mine's in radian mode. In your homework, you will be moving back and forth between degrees and radians. Remember, it's automatically radians if you don't see a degree symbol. So if you would pay attention, please. She said, how do I do it? I'm trying to show you. Right here in DRG, I'm going to go over to degree and hit equals. On the battery operated one, you just hit DRG and it'll cycle between degrees, radians, and gradians. Gradians are an engineering thing. But we don't use those. That's for engineers only. Okay? Degrees and radians. So just make sure before you do any work that your calculator is in the mode that the question is asking for. Okay? So cosine of 30 degrees is 0.866. Okay? So it worked out just fine. There's a degree symbol. That's how you know. You don't see degree symbols, automatically radians. Okay? And on your graphing calculator, you'll have to hit mode. You found it? Okay. So yeah, cosine of 30 degrees is exactly what we expected it to be, the 0.866. Now I got a question for you. How would we have gotten our calculator to do secant of 30 degrees? Because our calculators do not have cosecant, secant, or cotangent on them. So how would we get our calculators to do any of those three functions? Not the inverse. Inverse means cancel that function out. The opposite means multiply by -1. I don't know. What is it called? Someone said the right word. What is it? The reciprocal. That's why I called them the reciprocal functions. No, it's not basically what you said. You said inverse. No, I didn't, because the inverse of cosine is on the calculator, and it's something completely different from the reciprocal. It's not whatever. There's a difference. No, you're not, because you're wrong. They're completely different things. So how would we get our calculator to do the reciprocal functions? How would I evaluate secant of 30 degrees on this calculator? That's sine inverse. Yes. Okay. So, yeah, it's kind of hard to hear when everybody's talking, right? You want to say it louder for him, Seeger? Raise it to the negative first power. No, that is not what that says. That says sine inverse. That is a function. Okay. What does this say? We've learned it this year. What does that say? One of you remembers. Inverse. That says f inverse of x. That is not an exponent. I specifically told you that. This does not say f to the negative 1. This says f inverse. So when you put this little negative 1 symbol above a function type, like sine, cosine, and tangent, that is an inverse. This is sine inverse, cosine inverse, tangent inverse. Those are not raising our answer to the negative 1 power. So you could just use the exponent button and raise it to the negative 1, or there's a button for that. It's right there. It says x to the negative 1. And if you're using, so I'll just do like that and hit enter. Now, if you're using the battery operated calculator, it actually says 1 over x on the button. And it'll just give you the correct answer of 1.15. Why does yours say domain error? I don't know. Oop, that's a black pen, not a purple pen. You know what else you could have done? If you know that secant is the reciprocal of cosine, you could have just, how do we get reciprocals again? Like, what's the reciprocal of 3/4? 4/3. But what would I have to do to the 3/4? What makes it flip over other than a negative 1 exponent? What's the same as dividing by 1/2? Multiply by 2. You know why it's the same? Because reciprocal means 1 over. Reciprocal just means 1 over. So if you would like to do secant of 30 degrees, either know that you could do cosine of 30 degrees and then ask the calculator to reciprocate it for you, or just do 1 divided by cosine of 30 degrees. I prefer to do it that way. But there's more than one way. Completely up to you. Okay? Now you know. And that's true for all the reciprocal functions. You want to do cotangent? Fine. 1 divided by tangent of. You want to do cosecant? Fine. 1 divided by sine of. Okay? I don't know. Let's see it on camera. You're not the only one in the world with this calculator. Let's see what it does. So hold on. I'm going to type what you want me to type. Clear. What do you want me to type?
So, second, and then the pi thing.
Because that takes you to your trig menu.
Yeah, and then go all the way down to 5.
Because that's cosine inverse. That's not reciprocal. That is not what I said. I specifically said that is cosine inverse. I even pointed to it. That's why. You broke the domain of the inverse cosine function. That's why.
Mel, you're in the way.
Oh.
There you go.
It's actually for the video.
So do 1 divided by cosine of. Okay?
Okay.
Because cosine inverse is something completely different from the reciprocal of cosine. Yeah, she was doing her own thing when I was explaining. Scoot. Alrighty. Solving a right triangle means getting all of the sides and all of the angles. A right triangle has a hypotenuse of 8, includes a 37-degree angle. Figure out what the rest of the triangle is doing. Let's draw it in quadrant 1 in standard position. I'll even put the 37 degrees down by the origin where we would expect to see an angle in standard position. And we know that the hypotenuse is 8. Great. What we don't know is this x, or this y, or this angle right here. I think the angle is the easy one. How can I find that angle? So because our triangle is added to 180, I could subtract these two numbers from 180 to get this. Or because this is a right triangle, these two angles are always complementary, so I could just subtract this from 90, which is the same thing. So that's what I'm going to do. 90 degrees minus 37 degrees is 53 degrees. So this angle is 53 degrees. There. Now we have two unknowns, the x and the y, and we're going to find them using trigonometry. From this 37 degrees, which side is this? Opposite, adjacent, or hypotenuse? Adjacent. And this side is? Hypotenuse. Which trig function uses adjacent and hypotenuse? Cosine. So we know that cosine of 37 degrees equals x over 8. I'm trying to solve for x. What do I need to do? Well, yeah, I'll type that on a calculator, but how do I get x by itself? Multiply by 8. The reason why we're multiplying by 8 is because that's how you get rid of the bottom of a fraction, right? Or at least not get rid of it, but that's how you make sure you have no fractions, correct? Okay, so we'll get that 8 out of the bottom of the fraction by multiplying it over. And now we know that x equals 8 times the cosine of 37 degrees. We'll see what that is, and I guess we'll just round to 2 decimals. 6.39. Okay. I now know 2 of the sides of this right triangle. What's one way that I could find the third side? I could use the Pythagorean theorem, absolutely. But I don't want to do that. The reason why is because this is not an exact answer. This was a rounded answer. So when you can avoid using rounded answers to find other information, avoid it. Okay? If we didn't have a choice, well then we would do what we had to do. Luckily it's on the screen and I can just hit squared if I want to. But I'm going to avoid using that number and the Pythagorean theorem because that is a rounded digit. Cool? Instead, I'm going to ask myself, from this 37, what side is y? Opposite, and 8 is still hypotenuse. Could I use tangent and do opposite over adjacent? Absolutely. But again, that would be utilizing a rounded number. So when you can, use given exact information. This was given, it's exact. This was given, it's exact. Opposite, hypotenuse. Which trig function? Sine. We got a fraction. We know we don't want there to be a fraction. How are we going to make the bottom of the fraction no longer be on the right side? Multiply by 8, because that is what's in the denominator. Because multiplying by the denominator, you know, makes it no longer a fraction. Giving me, oh no, I wrote x instead of y by accident. That's not an x, it's definitely a y. Anywho, y equals 8 sine of 37 degrees. Rounding to 2 decimals is going to get me some number that I don't know. 4.81-ish. There you go. We did it. Do you have questions on that? No? Well, that's everything I wanted to teach you today. So that's going to end the lesson. So thank you, nerds. And now we're going to do a bunch of practice. And since you didn't skip school today, you're going to have a leg up. Congratulations.